Hello students, today we are going to study properties of aggregates. Now basic functions of aggregates. Cheap fillers, hard material, provide volume stability, reduces volume changes and provide abrasion resistance. Now characteristic of aggregate and their significance. Generally, aggregate properties affect not only the concrete mixture proportions but also the behavior of fresh and hardened concrete. Due to considerable overlap between the two, it is more appropriate to divide the study of aggregate properties into three categories that are based on microstructural and processing factors. Characteristic dependent on porosity, that is density, moisture absorption, strength test, hardness, elastic modulus and soundness. Next is the characteristic dependent on prior exposure and processing factors such as particle size, shape and texture. Now, characteristic dependent on chemical and mineralogical composition, that is strength, hardness, elastic modulus, deleterious substances present, etc. A knowledge of certain aggregate characteristics, that is density, grading and moisture state, is required for proportioning concrete mixtures. Porosity or density, grading, shape and surface texture determines the property of plastic concrete mixtures. The mineralogical composition of aggregate affect its crushing strength, hardness, elastic modulus and soundness, which in turn influences various properties of hardened concrete containing the aggregate. Now next is the property of aggregate. Absorption capacity is defined as the total amount of moisture required to bring an aggregate from the oven dry to the SSD condition, that is saturated condition. Now what do you mean by SSD condition? When all the permeable pores are full and there is no water fill on the surface, the aggregate is said to be in the saturated surface dry condition, that is known as SSD. Now next is the surface moisture. The amount of water in excess of the water required for the SSD condition is referred to as the surface moisture. Now next is the specific gravity. Is defined as the density of the material including the internal pores. Now next is the bulk density. Is defined as the mass of the aggregate fragments that would fill a unit volume. Now here oven dry condition is shown, here air dry condition is shown, saturated condition is shown and here damp condition is shown. Now next is the soundness. An aggregate is considered as unsound when the volume changes in aggregate induced by weather, that is alternate cycles of wetting and drying or freezing and thawing, results in the deterioration of concrete. Now Indian standard limits for fine aggregate is 10%, that is weight loss of 5 cycles with Na2SO4 will be only 10%. Now for fine aggregate, the weight loss of 5 cycles with MgSO4 solution will be only 15%. For coarse aggregate with Na2SO4, that is 12% and with MgSO4, that is 18%. Now next one is the shape, that is the flakiness index. Thickness being 0.6 times their mean dimension contributes more surface area for a unit volume occupied. Now this data is very important from the gate point of view as well as from other government exam point of view, because every time a question will ask from this portion. Okay. Now next is the elongation index. Greatest dimension being 1.8 times their mean dimension contributes more surface area for a unit volume occupied. Now this data is also very important from the government exam point of view as well as from the gate point of view. Now this type of aggregate is known as flaky aggregate. This is known as elongated aggregate and they are neither elongated nor flaky, which is shown here. Now next is the mechanical properties of aggregates. Crushing strength, impact value, abrasion resistance and elastic modulus of aggregate are interrelated properties that are greatly influenced by porosity. Aggregate from natural sources that are commonly used for making normal weight concrete are generally dense and strong, therefore they are seldom a limiting factor to strength and elastic properties of concrete. Now Bureau of Indian Standard Limit For crushing and impact value, that is wearing surface equals to 30% and non-wearing surface equals to 45%. Now for abrasion resistance, the wearing surface equals to 30% and non-wearing surface equals to 50%. Now next is the sizing and grading of aggregates. Grading is the distribution of particles of a granular material among various size ranges, usually expressed in terms of cumulative percentage larger or smaller than each of a series of sizes of sieve openings, or the percentage between certain ranges of sieve openings. Now next is the size of aggregate. The maximum size of aggregate is conventionally designated by the sieve size on which 15% or more particles are retained. In general, the larger the maximum aggregate size, the smaller will be the surface area per unit volume, which has to be covered by the cement paste of a given water cement ratio. Now next is the fineness modulus. Empirical factor called the fineness modulus is often used as an index of the fineness of aggregate, a very important factor when making selection for a source or type of fine aggregates. The fineness modulus is computed from screen analysis data by adding the cumulative percentage of aggregates retained on each of a specified series of sieves and dividing the sum by 100. The sieves used for determining the fineness modulus are sieve number 100, that is 150 micrometer, sieve number 50, that is 300 micrometer, sieve number 30, that is 600 micrometer, sieve number 16, that is 1.18 mm, sieve number 8, that is 2.36 mm, sieve number 4, that is 4.75 mm, and 10 mm, 20 mm, 40 mm, etc. As per our experience, fine aggregate with fineness modulus of 2.6 to 3 are best suited concrete application, and fine aggregate with fineness modulus of 2.4 to 2.6 are best suited for plaster applications. Now next is the silt content. Material finer than 75 micrometer sieve are generally called silt. They affect the workability as water demand increases. Strength is also influenced along with bonding. Bureau of Indian Standard limit is 3% by weight. Now, by volume, silt to be less than 12% after 10 minutes. As river sands are prone to be silty and its dredging from riverbed affects environment, manufactured sand are slowly replacing them at the metropolitan cities. That is all about the properties of aggregates. Thank you very much, students.